Hey, what's up, Josh? How you been? Nice to hear from you. You keep beating me badly in chess, but I'm going to keep trying. I got to focus in a little bit better. But thanks for taking the time to play me on there. Let me know if you've got any pointers for me. So, I see you had this question on number 28 from section 9.7. This is on page 517. These ones were quite tricky, and especially when it's just asking us to verify the identity as it breaks down on that previous page in examples 3 and 4, where really we're trying to see if we can use our fundamental identities from the chapter to verify that the identities that they're giving us in these problems are in fact true. So basically we want to begin with the expression on one side of the equation and see if we can use algebra or the trigonometric properties to manipulate the expression until it's identical to the other side. So I want to walk through this one because the first thing is on this one is this interesting notation like sine squared of negative x. As you may have seen in one of my other videos, instead of writing, this actually means this whole thing sine of x, or sorry, I should say sine of negative x squared. We put the square right there because you could imagine if we were saying sine of negative x squared like this, without these parentheses, of course, you might get confused that just the negative x were squared and not the whole thing. So that's why in these, using this trigonometric notation, we put the squares in that spot between the trigonometric function's description and the input. So what you may notice is that one of our angle identities is that the sine of negative theta is actually equal to negative sine of theta. It's the sine of a negative angle measurement is equal to negative sine, which makes sense because, like, for instance, the sine of an angle is the vertical displacement if we think about our unit circle here. So, and then the sine becomes negative when the angle is negative, so it makes sense for these to be the same. If we switch the angle to negative or just took that measurement, made it negative, either way we would get the same negative measurement. So that's the identity, and that's on page 514 at the bottom. You'll see the negative angle identities. So the first step we're actually going to be able to do is we're going to just try to rewrite this instead of as sine squared of negative x. Let's try rewriting as negative sine of x all squared, because we're able to do that given that first property. We'll leave the rest the same for now, but let's just try to keep simplifying this left side. I'll just bring that right side down. And what we know is that whenever we square something, it becomes positive. So this actually, we could just get rid of the negative and it would just become sine of x, whole thing squared, which we write in this way, and tan of x, whole thing squared. So what you may now think about in terms of tangent and is that tangent, when it's in the denominator like this, it's one of our reciprocal identities. Is that tangent, we could, instead of writing it as tangent squared in the denominator, we could write it as cotangent squared. So instead of sine squared, let me erase this so we don't get confused. Instead of sine squared divided by tan squared, we could rewrite it as it's the same as multiplying by its reciprocal. So I could do sine squared of x times cotangent squared of x. And if you remember, cotangent squared of x is actually it's actually cosine over sine. And since it's squared, those would also have to be squared. And so if you look right here, we could see if we keep simplifying just this left side of the equation, those signs would cancel and we're just left with cosine of x squared, which is exactly what we had on the right side. So these problems are kind of, they're very algebraic in nature. I can see looking at your work You did quite a nice job with 3, 7. Your description for 11 was spot on. You just simplify it. 23, you did a nice job finding the fact that, cosecant is the reciprocal of sine. 27, you did similarly, using a nice job on your reciprocal. Your identities. So this one was the trickiest. That's why I assigned it as the last one. But hopefully this explanation helped show you the path to using these trig identities. It's just sort of a nice algebraic exercise involving some nice trig as well for us. Hope you enjoyed this video. Hope you're doing well. I'm sending you you and your family my very best during this pandemic, and I look forward to connecting again soon. Catch you later.